All right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for Murock's Android Programming Second Edition by Joel Murock for the AWD1112 or 1112 Java Programming class. We are up to Section 4 of our textbook, and in Section 4, which is chapters 13, 14, 15, and 16, starting on around page 395, we're going to develop a task list app. In Chapter 13, we'll talk about SQLite and how to work with a database. Chapter 14, we use custom tabs and custom adapters to display data on the user interface. Chapter 15, we use a content provider to make data for an app available to other apps. In Chapter 16, we learn how to create an app widget that can display the app's data on a device's home screen. So, let's get started. You'll notice we have 6 applied objectives and 5 knowledge objectives. For the applied objectives, create a database class that works with a SQLite database, write code that creates or upgrades the database, write code that opens or closes a connection to the database, write code that retrieves one or more rows from a table in the database and works with said data, write code that inserts, updates, and or deletes rows from a table in a database, test the database class to make sure it's working correctly. Those are our 6 applied objectives. For our knowledge objectives, describe the characteristics of a SQLite database, explain what is meant by an embedded database, name and describe the 3 data types supported by SQLite, describe how you can use Android Studio's Android Device Monitor to copy a file from a device to your computer, and describe how you can use a third-party tool like the DB browser for SQLite to work with database files. Now, we have worked with databases before. The database that we work with, actually 2 of them, were MySQL and SQL Server. And what you'll find is when you work with SQL, SQL is SQL. In other words, the main ways of manipulating a database, doing CRUD operations, create, read, update, and delete, all right, those being done basically via a select statement for read, create for create, insert, update, and delete, respectively. So this is the app that we're going to create. It'll also be take our stuff and it'll basically break it into 2 different categories: personal tasks and business tasks. Okay? So the author says here, when the app starts, the task list activity will display a list of tasks where each task has a checkbox that indicates whether it has been completed. Each task will have a name and have a place where you can optionally put some notes in. Again, we'll have 2 tabs for the list, a personal tab and a business tab. You can mark a task completed by selecting a checkbox. You can remove tasks by using the little trash can that's right there. You could add a task by clicking the plus bar that's there. You could edit a task by clicking on the task list activity and making whatever changes you want. So the author says at the bottom of page 398 and 399 in figure 13.1, but on the bottom of 398 he says, take a moment to reflect on the app, on the data this app needs. First, it needs the names of the list. Second, it needs at least 4 pieces of data about a task: the list it belongs to, the task name, any notes, and whether or not it's been completed. And that's what this chapter is all about. So, what is SQLite? Well, it's a relational database management system. As we've learned earlier, a relational database management system uses what? It has characters, which are anything basically you can key in from the keyboard. 1 or more characters put together results in a field. One or more related characters is a field. One or more related fields is a record. One or more related records is a table. One or more related tables is a database. All right. Like MySQL, like SQL Server, SQLite is standards compliant, so it implements most everything in the SQL standard. It's embedded, which means it does not run in a server process. All right. Rather, it's embedded as part of the client app and runs in the same process. It's zero configuration, which means it's available on each and every Android device, and it requires no database administration. It's lightweight. All right. The library is approximately 350K, which for a database is very light. It's secure. The SQL database that you work with is only accessible by the app that created the file for the database. It's popular. And it's open source. Now, SQLite supports only 3 types of data: string, long, and double. So if you're working with other Java data types like date, time, and Boolean, etc., you'll have to convert them into one of these 3 types. Also, SQLite is weakly typed. In other words, if you say that a field is a numeric field and you put a string value in there, eventually the program will blow up, but it won't right away as it would with other relational database management systems. So again, here are our 3 SQLite data types and their equivalents: text, integer, real, which are again string, long, double. So this is the task database. It's pretty simple. There's 2 tables. There's a list table and there's a task table. Now you'll notice that it's kind of a standard or an unwritten standard for SQLite to call your primary key _ID. These are not the same field. This is the list ID and this is the task ID. So the list ID has only an ID and a list name in it. So the list table has an ID and a list name. The task table has an ID. The list ID, which is this here, so that's put in there as a foreign key so that we're able to relate the tables together. A task name, any notes, the data was completed, and you're able to hide it if you don't want to show it. This is a one-to-many relationship, so this says that every one list can have 0, 1, or more tasks, but every task that's in here belongs to only one list. Now here is the SQL that creates the list table and the SQL that creates the task table. This shouldn't look very new to you, all right? Other than, again, since we only have integer and integer and text and real, okay? You see most everything is going to be, everything has to be one of those types. In this case, just integer and text. You can use auto increment. We've dealt with that before. You know that a primary key is a unique record identifier. You know that not null means that these cannot be left blank. Drop table. So there's create table, the table name and the values in curlies. Drop table. Okay. We've talked about all this stuff before. So again, you should know what a primary key is. One or more fields that uniquely identify a record. You should know what auto increment is. There can only be one of these per table. An auto increment column is defined typically with an integer data type. By default, it starts at 1 and it adds 1 with each new record. Not null means that the column can't store null values. Not only can you have not null, but you can have unique. And again, creates a table, delete removes a table and all of its data. Now, what we did go into last semester, but probably not nearly the depth and the breadth of coverage that we should have, and that is to start to talk about the tie-in between writing databases, writing a database, creating a database with tables, and the associated source code. Now, what you see on the screen here, and here, and here, and here, and here, and here, and here, okay, etc. What you're seeing there are the business objects for the task list app. These business objects are classes mapped to the tables of the database. For example, a row in a list table can be stored in a list object. A row from the task table can be stored in a task object. When you work with databases, it's normally considered a good practice to map rows to Java objects like this. All right? This provides access to what are called POJOs, or plain old Java objects. Now, the list class that you see on the next two slides, this one and the next one, and also in Figure 13-4 on page 405, defines an instance variable for each column in the list table. Since there's only the two columns, the ID and the name, there they are. Then there's three different constructors. A constructor with nothing passed in, a constructor with a name passed in, and a constructor with an ID and a name passed in. Next, it defines the associated set and get methods for ID and name. And finally, it defines a toString method that provides a way to convert a list object into a string. And the task works pretty similarly. What's new in here is what we've done is we called true 1 and false 0. Didn't have to do it that way, but that's pretty much the way that it's typically going to be done. So again, this is the code on 405. It's in Figure 13-4 on pages 405, 406, 407. And again, you can see how similar it is. So the next thing that's shown in Figure 13-5 that's on pages 409, starts on page 409, let's put it that way, and is on 411, and is on 413, and is on 415. So on those 4 or 5 pages, and 417, so you can see how long this is, and 419, and 421, and 423. All right? This is the code that we use to work with the database. Now, the author says this approach allows you to store all of the database code for the app in a single class, which is generally considered best practice when possible. That said, you don't want your code to be, the class to be hundreds and hundreds and hundreds of lines long, because that doesn't make sense either. But when possible, it's generally considered a good practice to define all of your stuff into one class. Also, as you can see here with these constants, it's considered a good practice to define constants for the name and the version number of the database, and for the table names and the different column names and numbers. So, the task list DB class begins by defining constants for the name and version number. The DB version specifies the database version. It also defines the constants for the list and task tables, including the names of the tables, the column names, and the column numbers. Once all of this stuff has been done, as is shown in Figure 13-6 on page 411, it can build the create table statements that are used to create both the list table here and eventually the task table. Not only the create table stuff, but the drop table stuff. On figure 13-7 on pages 412 and 413, we have a DB helper class that extends the SQLite open helper class. It begins by defining a constructor, which contains a single statement that passes 4 values to the superclass. The class then overrides the onCreate superclass. If Android doesn't find the specified database on the device, it executes this method instead. After the onCreate method, the class overrides the onUpgrade method. If Android finds the database on the device and a newer version is available, it'll execute that. Now, it's considered during development time a common practice for the onUpgrade method to drop a database and recreate it. The problem with doing this is it removes all the data. And you don't typically want that in a production type of app. So you only want to do that during testing. There's also, and you can see it in here, an exec SQL method that's available. And what that does is it executes SQL statements. Now, much of the work that's done with this, just so you're aware of it, much of the work that's done with this stuff is done in a very similar method in other programming languages as well. So the code that you see here is figure 13.8 on pages 414 and 415. This code shows how to code the private method that make it fairly easy to open and close database connections. These private methods, as you'll see in just a bit, are used by the public methods that are going to be looked at next. The code here begins by declaring the SQLite database and the DB helper object as instance variables. The SQLite database object defines a connection to the database. The DB helper object contains the methods that can open that connection. Then you've got your constructor, and the constructor creates an instance of the DB helper object. Following that, we've got the open readable DB method that calls the get readable database method from the DB helper object to return an SQLite object with a read-only connection. Since it's read-only, of course, you can't write data to it. Then we've got an open writable. All right. This returns an SQLite data object for a read-write connection, so you can either read the data or write the data. Finally, we've got a close DB method, and the close DB method basically begins by checking to make sure that the object exists. It's considered best practice to do this. So this get readable DB's database opens a database or creates a connection that's read-only. The get writable database opens a read-write connection. Finally, the close closes the connection. Within a database class, you use these private methods for opening and closing a connection to the database. All right, the next thing that's discussed starting on page 416 is how to add the public methods. Let me check my time, which must be getting up there, and it is. So what I think I'm going to do is stop right here, and I will pick it up in the next video talking about these public methods and testing the database, and finally a little bit on how to use DB browser for SQLite. All right, so I will be back with that video very shortly.